I'm on top of the world, I'm on top of the world, we've done this for a while now, paying my dues to the dirt. I've been waiting to smile, the whole thing for a while, take you with me if I can, been dreaming of this job, I'm on top of the world.
Hello everybody, and well done for your work in maths so far this week, including on equivalent fractions yesterday. Now this can be an area of fractions where some people are a little bit shaky sometimes, but I was really pleased with how you all did yesterday. So let's have a look at equivalent fractions 2 today, where we're going to be moving from relying on the bar models and comparing the size of the fraction in bar models, and we're going to be looking at the more abstract way of finding equivalent fractions using our knowledge of our times tables and our multiples. So you are going to need your pencil, your exercise book, or your math templates from Seesaw. When you've got those things, you can continue. Okay, so let's have a look at our flashback form. Pause the video and have a go at these 4 questions and at naming the 3D shape in the top right hand corner. Okay, how did you do? I'm going to help you go through these now to see how you did. So let's have a look at number 1. It says subtract £5.70 from £12. This is a skill that you might need to do when you're in your real life, if you're shopping or finding change or thinking how much money you've got left. So to subtract, I think what we could maybe do, I mean, you could do a column method, but I'm going to find the difference, and I'm going to use a mental method, which I could do in my head, but I'm going to show you what's going on in my head. I'm going to write it down, finding the difference between £5.70 and £12. So I'm going to start with £5.70, and I'm going to add to get to the next full pound, which is £6. And what I have to add there to get to £6 is 30p. So far I've added 30p. Then to get from £6 to £12, all I'm going to have to add there is £6. So I've added £6. And the difference between £5.70 and £12 is what I've added. I have added £6.30. Brilliant. So that's number 2. No, it's number 1. Oh my goodness. Right, number 2 next. It says round £6.78 to the nearest pound. I know that £6.78 is in between £6 and £7, and halfway would be £6.50. Well, £6.78 is past halfway, isn't it? It's about here. So the nearest pound is £7. That means £6.78 rounds to £7 to the nearest pound. Number 3, write 1/4 as a decimal, which we did learn when we were practicing decimals a few weeks ago. Can you remember? The decimal is 0.25. And the reason for that is because there are 100 hundredths in a whole one, and a quarter, 1/4 of 100 is 25. So that's why 0.25 is the same as 25 hundredths or 1/4. Fantastic. I just am going to pause the video and clean my whiteboard before we try number 4. Brilliant. So for number 4, we've got to draw a rectangle with a perimeter of 14 centimetres. And remember, perimeter is the distance all the way around the edge of the shape, and we're drawing a rectangle. So a rectangle has got 2 longer sides and 2 shorter sides that are equal. So there are various different answers that you can have for this question, and if I start being quite logical about it as systematic, I might imagine that my shorter sides were just 1 centimetre each. And now if the perimeter is 14 centimetres, that leaves me 12 centimetres to split between my 2 longer sides, doesn't it? So that means each of the longer sides is 6 centimetres. That is one possible answer. And you've guessed it, if we're going to be systematic about it, the next one I'm going to try and show you is if the shorter sides are 2 centimetres. So if the shorter sides are 2 centimetres and there are 2 of them, that's 4, and I've already used 4 of my 14 centimetres. that leaves 10 centimetres to split between my longer sides, and that's 5 on each of the longer sides. So there's another possibility. Let's try another one. Let's be logical about it and systematic and make our shorter sides this time 3 centimetres. And can you see there's a pattern that is emerging? So as this shorter side is 3, we've used 6, and that leaves us 8 to split between the 2 longer sides, so that's 4 centimetres. So the pattern that we saw in all of these different possible answers, whereas the shorter side has got one bigger, the longer side has got one smaller. And if I was to continue the pattern, they would just switch here, wouldn't they? So we've got them all now. We've found all the possible answers. Didn't even ask us that, and we've done it. Finally, it's a ball, but no, what do we call the ball of a 3D shape? A sphere. Well done. So I'm so proud of all the amazing maths you keep doing in year 4 when you're at home with your learning. It's absolutely brilliant. And equivalent fractions even. So as we saw yesterday, you're nice and confident with using bar models to compare fractions to see if they are equivalent or the same or equal. So we're going to have a look at one more kind of diagram to show how we can show equivalent fractions using a diagram, and then we're moving on to the abstract method, which we don't need to draw diagrams for. So here's a way of showing using a diagram to show equivalent fractions. Here I've drawn a diagram which has got thirds, and I'm going to shade in one of the thirds. Now to find an equivalent fraction to this, I'm just simply going to draw the diagram again, exactly the same, except that this time I'm going to split my diagram in half horizontally. Now if you can see, if I was to shade the same amount of my diagram now as what was a third, I've actually shaded 2/6. And so that is another way of using a diagram to show equivalent fractions. Let's have a look at one more. There we go. So I've drawn, this time I've drawn 3/4. Now I'm going to draw that diagram again, but this time I'm going to split the diagram horizontally into 3 parts. I'm trying to make it equal. There we go. Now this time that means that I have got 12 equal parts altogether. So I'm looking at 12ths here. And if I was to shade the same amount as I had before in 3/4, this time I now have 9/12ths. So the first few questions on your sheet today involve using fraction diagrams like this that have been then split horizontally into 2 or more different parts, 2 or more different rows. There we go. Okay, so that brings us on to thinking about how we can find equivalent fractions without using a diagram. And here are a whole list of fractions that are all equivalent. They all have the same value. So I've just taken 2 of them here to see if you can remember how we actually work out that a pair of fractions is equivalent without using a diagram to compare the size. And I wonder if you can remember it. If you can remember it, see if you can write it down or tell someone at home or just tell yourself. Okay, so the way that we do that is that we multiply or divide the numerator and the denominator by the same number. This is going to come flooding back to you if you hadn't already remembered it. So in this instance, 1 has been multiplied by 2 to become 2. And the denominator has been multiplied by the same number, also by 2. 4 times 2 is 8. Let's look at the next one on the list. Okay, and now we've got 1/4 is also equal to 3/12. And remember what we said? We said that if we multiply or divide the numerator and the denominator by the same number, then we will have found an equivalent fraction. So here it is again. This time 1 has been multiplied by 3 to make 3, and 4, the denominator, has been multiplied by 3 as well. 4 times 3 is 12. So the rule is you multiply or divide the numerator and the denominator by the same number, and that will give you an equivalent fraction. Let's have a look at the next one. 1/4 is also the same as 5/20. This time each of the numbers has been multiplied by 5. 1 times 5 is 5 and 4 times 5 is 20. And 1/4 is also equal to 10/40. What has the numerator and the denominator both been multiplied by this time? That's right, they've both been multiplied by 10. So that's brilliant. And that is our rule. Just say it to yourself again now, me then you. Multiply or divide the numerator and the denominator by the same number to find an equivalent fraction. Your turn. Great! So quite often what you will find is that you are given a pair of fractions with an equal sign in the middle, which tells you that they should be equivalent. But part of one of the fractions were missing, and you've got to use what you can see to work out the missing part of the fraction. So in this case, we know that we've got to multiply the numerator and the denominator by the same number to find an equivalent fraction. And we can see that the denominator has been multiplied by something. 6 multiplied by what is 18? That's right, it's multiplied by 3. And that tells us that we have to also multiply the numerator by 3. 1 times by 3 is 3. So that tells us that 1/6 is equivalent to 3/18. Let's have another go. Okay, this time our space is on the left. So let's see what we can do. Let's have a look. We've got the numerator, both numerators, so let's look at them. To get from 3 to 1, we divided by 3. It got smaller, so it must have been divide, not times, to go that way. And so that means we have to also divide the denominator by 3 as well. 12 divided by 3 is 4. And that tells us that 1/4 is equivalent to 3/12. Okay, so you try now. Here are 2 pairs of equivalent fractions with a missing number. See if you can work out the missing part of the fraction each time. Just pause the video and then start again when you've had a go. Fantastic. Okay, so to get from 7 to 14, we needed to multiply by 2. So that means we need to also multiply the numerator by 2. Doesn't matter what we're multiplying by here, that'll be different numbers each time, but you have to multiply or divide the numerator and the denominator by the same number or it won't be equivalent. So let's have a look. 1 times by 2 is 2. Done that one? So what did we multiply 5 by to get to 20? By 4. So now multiply the numerator by 4. There you go. Excellent. So 2/5 is 8/20. Fantastic. So have a go at your sheet now. Questions 1 or 2 are using the diagrams that we showed you, and question 3 and 4 are also are using the multiplying or dividing the same, the numerator and the denominator by the same number. So have a go at those. Have a go on the second sheet as well, everybody. I am going to go through question 5 and 6 with you in a moment, just to explain that sorting diagram there and the other problem 6, which has got lots of possible different solutions. Okay, so let's have a look at question number 5. We've got to write the fraction in the correct place on the sorting diagram, and this kind of diagram, you've probably met it before, is called a Carroll diagram. So we need to put the correct fractions that are listed there into the right box. If it's in this square, it's equivalent to 1/3 and it's got an odd denominator. If it's in this square, it's equivalent to 1/3 and it's got an even denominator. So this box is equivalent to 1/4 with an odd denominator, and this box, it's equivalent to 1/4 and it's got an even denominator. And I'm going to work through each of the fractions in turn. So first of all, we've got 8/24, and I've got to think, is it equivalent to 1/3 or 1/4? Well, let's just try it out with 1/3. If I divide 24 by 8, I get 3, and also if I divide 8 by 8, I get 1. So 8/24 is equivalent to 1/3. Brilliant. Has it got an odd denominator or an even denominator? That's right, it's got an even denominator. So 8/24 goes in this box. If I was to try that one out with 1/4, just to show you, it wouldn't work, because let me just rub all the other stuff out of the way to make it a little bit clearer. There we go. So 24, what do I divide it by to get 4? I divide it by 6. But again, that doesn't work there. I can't do 8 divided by 6. It's not 1. So no, it isn't equivalent to 1/4. So just to show you that whichever way you try, you'll find out if it is equivalent or if it is or it isn't equivalent using this method. Right, let's see if we can second guess this next one quite quickly. So 3/12, do you think it's going to be equivalent to 1/3 or 1/4? We could divide 12 by whatever to get 3 or 4, but what are we going to divide that numerator by to get 1? We're going to divide it by 3, aren't we? So we must be dividing it 12 by 3, and that'll give us 4. So there we go. 3/12 is equivalent to 1/4. Does it have an odd denominator or an even denominator? It's even, isn't it? So 3/12. Okay, one more from me, and that's 5/15, and that one kind of jumps out at me. Does it jump out at you? I know that 5 is 1/3 of 15, so that is that, and each one's divided by 5. Brilliant. I'm so good at this. So where does that one go? 5/15. It's equivalent to 1/3 and it's got an odd denominator. So I'm going to quickly put the rest of them in. And the final part of the question asks us if that any of the boxes are empty and why we think that is. So I've just been having a little doodle down here to explain that to you, because there are no fractions that are equivalent to 1/4 with an odd denominator. And I thought I'd go back to the bar model here, because 1/4 is 1 out of 4 boxes. So no matter what number is in the 1/4, by the time we've got 4 of them, we've got an even number, haven't we? Because we've multiplied it by 4, we've multiplied it by 2 and then by 2 again. And even if we put an odd number in here, like I've done 5 little dots in there, which was an odd number in 1/4, by the time I've got two of them, that has become an even number. That little odd one and that little odd one have become a pair, haven't they? So multiplied by 4 is also the same. Whatever I multiply by 4, it's going to be an even number. And that's why we don't have any equivalent numbers with an odd denominator. Because that one would be 5/20, wouldn't it? And that would be an even denominator. There we go. How are you doing? You doing okay? Let's have a look at number 6. I'm just going to start you off on this one in case it's a little bit confusing to start with, and then I think you'll be good. So the question says, find three ways to make the fractions equivalent. And so for 6a, we've got the numerator is of the both equivalent fractions is the same each time, 2 and then 4. And that tells us that we are always going to be multiplying by 2 each time. And as you know, whatever you do to the numerator, you must also multiply the denominator by the same amount. So basically it doesn't matter what number we put down at the bottom here. So let's start off with like a quite straightforwardish one. Say it was 4. I would then have to multiply that 4 by 2 and get 8. Fantastic. Must multiply it by 2. That's the thing. So let's say I did something different. Let's say I did 2/10. Okay, I must multiply it by 2. And so that would become 4/20. And let's say it could be something crazy like, well, whatever, 16 2/16. I must multiply it by 2 or double it with the same as 4/32. So that should help you, hopefully. Looking at B, the numerator is always 1 and 4. So what do you multiply the numerator by each time? Great, you've got it. You multiply it by 4. So you must also each time multiply the denominator by 4. Choose a different number for each of the 3 examples, but always multiply it by 4. Fantastic, and I think you'll have cracked it. Okay, so if you're still going strong, let's have a look at the problems of the day. Use greater than, less than or equals to make these number sentences correct. Then number 2, there are 1,500 children in a school. 565 of the children are girls. How many more boys than girls are there in the school? So I would have thought sort of straight away, I was thinking, oh, so if there's 565 girls, how many boys are there? And I do need to work that out. But then the question I want to know is how many more boys are there than girls in the school? So there's going to be a 2-step problem there, year 4. And then the tricky number 3, which uses fractions. In fact, it uses equivalent fractions, but we'll come on to that. Mr. Patel writes the number on the board. Leon finds half of the number. Sophie finds 1/3 of the number. Leon's number is 7 more than Sophie's. What is the number Mr. Patel started with? This bar model may help you. So good luck with those. I'll go through those with you when you've had a little go. Okay, well done. Let's have a look at comparing these with greater than, less than or equals. So we've got 9 times 7 and 8 times 7. Well, obviously 9 times 7 is going to be bigger than 8 times 7, so that's that one way round. 48 divided by 2 and 48 divided by 4. Well, it's the same number and it's divided into more pieces, so the pieces will be smaller on this side, won't they? So this is the smaller side. Fantastic. And then 300 times 2, well, that's 600, it just pops in my head there. And this one also, let's use our smile. So 2 times 3 is 6, and then we've got those 2 zeros, is also 600. So well done. That's equals. Okay, so number 2, there are 1,500 children in the school and 565 of the children are girls. So let's see how many are boys so far, first of all. So 1,500, subtract the girls, 565, and let's see what's left. There are lots of zeros on the top row, so we are going to have a little bit of exchanging to do. I have to take it right back to the hundreds and exchange from the hundreds into the tens and then into the ones, just like that. 10 subtract 5 is 5, 9 subtract 6 is 3, 4 subtract 5, I haven't got enough, so let's just borrow that one. Exchange that from the thousands. 14 subtract 5 then is 9. So we've got 935 boys. That's 565 girls and 935 boys. Well, there's a lot of boys compared to girls. The question is, how many more boys than girls are there in the school? I need to find the difference. So to do that, I do subtract. Okay, 935 subtract 565, and let's find out how many more boys there are. 3 subtract 6, I haven't got enough. 13 subtract 6 is 7. 8 subtract 5 is 3. Brilliant. There are 370 more boys. There you go. Fantastic. Okay, let's give this one a go. Let's have a look. Mr. Patel writes the number on the board. Leon finds half the number. And Sophie finds a third of the number. So we've got a bar model which we've been suggested that we could use to help us, and the bar model shows halves and a third, because Mr. Patel's number was the same number that they both used, and Leon found half of it, which is this, and Sophie found a third of it, which is this. And Leon's number ended up being 7 more than Sophie's. Well, if look, that's the size of Sophie's. I'm just going to put a little dotted line down there. So Leon's ended up being 7 more than Sophie's. Now, what I'm going to do to continue with this problem is I'm going to use my knowledge of equivalent fractions, because I know that that half and a third, I can put those using the similar denominator here, the same denominator, should I say. So I know that if I was to write 1/2 as sixths, that would be 3/6, and I can actually split that diagram into sixths, and Leon's 1/2 is now worth 3/6, and equally I can write Sophie's 1/3, and the equivalent fraction in sixths is 2/6, and I actually can see that on here, 2/6. So there we go. Now, as that diagram now really nicely shows, that difference there of 7 of Leon's number and Sophie's number is actually 1/6 of the whole number. So each of the sixths is worth 7. Okay, that means that the whole number is 6 times 7. So Mr. Patel's number to start with was 6 times 7, which is 42. Fantastic. So as you can see, Leon found half of his number, which was 21, and Sophie found 1/3 of his number, which was 14, and the difference between those two was 7. So that was pretty cool. Well done. Well done, you. Yet again, you've worked exceptionally hard, and never ever worry if those problems of the day make your head spin a little bit. It's absolutely fine. It is more like year 6 maths, isn't it? So it's just there to give you that little extra challenge if you want it. In fact, same goes for any of the maths. Really never worry if you're feeling a little bit confused by it, because we'll sort it all out and we'll go over it again in the future. But well done today on your fantastic work, and I'm looking forward to seeing it on Seesaw.